So whenever we start with trigonometry, we're going to start with our trig ratios. So we have the three listed here: sine, cosine, and tangent. Now these are ratios that exist within acute angles within right triangles. So we have A and B as our acute angles, and we can write ratios from that based off of each one. So we start with sine. Sine we know as the opposite leg over the hypotenuse. So it's a ratio, it's a fraction that exists within the triangle. So if I pick angle A, the opposite leg to that is little a, the hypotenuse is C. That's A over C. Now if I look at angle B and say sine of B, the opposite to that is little b, and the hypotenuse is C. So that ratio, that fraction, is what we're looking for. Cosine is the adjacent over the hypotenuse. So in this case, at A, we're looking at the adjacent is B over C. For cosine of B, we're looking at A over C. And if we stop right there, we notice that sine of one angle is cosine of the other, and same works for there. So this is a pattern that we'll start to develop as we keep going. Tangent is going to be the opposite leg over the adjacent leg. So we're going to go for angle A, it'll be A over B. Then for angle B, it'll be B over A. Now in these, we notice that they are reciprocals of one another. So we have to first identify or just understand what our ratios are. So this is where we have SOHCAHTOA as a way to remember. And SOHCAHTOA says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's something we can pack up and then unpack whenever we need to figure out which ratio we're looking for. But we're not even going to necessarily use that as we start to solve. I have another approach I want us to take. So let's say I have a triangle. And in my triangle, I'm going to call this angle theta. Now theta is just a symbol we use to talk about angles. So in this one, I'm going to look at sine. I know sine is opposite over hypotenuse. Well, if I make this into a proportion of sine is opposite over hypotenuse, sine of 1 is opposite over hypotenuse, and at this angle, this is opposite, and this is the hypotenuse. So I could then say that sine of theta over 1 fits into that ratio. Now, I could do the same thing with cosine. Cosine is adjacent over hypotenuse. So if we did cosine over 1 equals adjacent over hypotenuse, we could go cosine theta over 1 to be there. Now, what I did here is I give us this triangle that we're going to use as a reference triangle for all trig problems. But we're going to add something to that. We haven't covered tangent. Tangent we're going to determine as sine over cosine. And that's because if I'm looking at my angle here, tangent is opposite over adjacent, which would be sine over cosine. But another way is we could look at the examples we did up here. Let's look at tangent of A. If I'm telling you that tangent of A is sine of A over cosine of A, then sine of A, which is A over C, over cosine of A, which is B over C, I have A over C divided by B over C. Both have C as a common factor. I can simplify it out. Now it's A over B, which is what I said tangent was. So really, tangent is sine over cosine. So this is the other thing we're going to use. So these are two tools we're going to do any trig problem. We don't necessarily have to remember SOHCAHTOA. We'll practice a little bit to make sure we can identify, but this is our method for solving. It all relates back to similarity and solving with proportions. So let's just first get some basic identifying out of the way. I have a right triangle here. It's a 12 and 5. Hopefully by Pythagorean theorem we understand that we could find the third side. It is also a Pythagorean triple, and that comes out to be 13. So sine of A is opposite over hypotenuse, 5 over 13. Cosine of A is adjacent over hypotenuse. Tangent of A is opposite over adjacent, so that's 5 over 12. Sine of C is 12 over 13, opposite over hypotenuse. Cosine of C is adjacent over hypotenuse, 5 over 13, and tangent of C is 12 over 5. Now the patterns we talked about earlier, sine of one angle is cosine of the other, that still holds up, and then the two tangents are reciprocals of one another. So it's just the identify and just understand what the ratios are. It's not really solving in any sense here. That's what we're going to go to next. So first off, we're going to start with solving a side. I'm going to draw my reference triangle next to it. Whenever I draw it, I need to make sure it matches so it's similar in the correct form. So I'm going to put theta in the same corner as the 28 degrees. Then it's sine theta, 1, and cosine theta. So if I look at it, I'm thinking that theta is 28 degrees in this problem. Okay, if I do that, I now have angle-angle similarity between these two triangles. So I can solve with a proportion. I'm going to do sine of, not theta, 28, over x equals, I'm going to go 1 over 19. So I made a proportion. I didn't use cosine because I didn't have a value to match it with. And from here I can do cross product. By cross product I get x equals 19 sine of 28. Now we're going to type this into the calculator here. If you're not sure on how to type them into the calculator, I'll link to the other video I have that explains that. If you haven't done that before, it'd be a good thing to check that out. I go through the different types of calculators you may come across. But here I'm going to do 19 times sine of 28, and I get that x is approximately 8.9. So that's the answer. That's our side. We found that using trig. Notably, sine helped us out. Let's look at the next one. I'm going to draw my triangle. Same direction here. I got the right angle. Theta is where the angle is. Sine is opposite to the angle. Cosine is adjacent. And 1 is the hypotenuse. So we're going to go cosine theta over, not theta though, let's go 41, over 32 equals sine 41 over x. So by cross product, I have x times cosine 41 equals 32 times sine of 41. But I want to get x by itself. Now cosine 41 is a value. It's a placeholder for another decimal that I have. So I'm going to divide it over to both sides, and I get 32 sine of 41 over cosine 41. Now I could then go to the calculator, type that in, and get the decimal value. But we can clean this up a little bit because sine over cosine is tangent, and make it 32 tangent 41. In any case, when I type that into the calculator, I should get about 27.8. On to our next one. This one was a little bit different. We have to make sure we get things matching up. A few mistakes occurred on this. We're not paid attention to the order. 21 degrees is at the top. Theta has to go there. Sine is opposite to theta. Cosine is adjacent. 1 is the hypotenuse. So as long as we get that set up, we're going to be in good shape. So I have cosine of 21 over x equals 1 over 26. So from here, I'm going to do cross product. I get x equals 26 cosine of 21, which gives us about 24.3. In our next one, I'm going to draw a triangle in. I got theta, sine, cosine, and 1. So here we're going to have sine of 55 over x equals cosine of 55 over 8. We're going to do cross product, and this becomes x times cosine of 55 equals 8 times sine of 55. I want to get x by itself, so I divide both sides by cosine, and I have 8 times sine of 55 over cosine of 55. Now, could just put that in the calculator and do both sine and cosine, but it is also equivalent to saying 8 times tangent 55, because tangent is sine over cosine, and we get an answer of about 11.4. Now, so far, we've been solving for sides. The next problem transitioned to now we actually solve for angles using trig functions, but notably the inverse trig functions. So let's see how this develops. So we have 1 sine, cosine. We're going to go 24 is to 1 as 24 is to 1 as 15 is to sine. We're going to do sine x, because I don't know what x is. I'm solving for it. So by cross product, we get 24 sine x equals 15, and eventually get sine x equals 15 over 24. Now this brings us to a different point than what we already had in the problems. In the other problems we had 21, like here, like cosine of 21, which is a number, and we can multiply. But now we have this x, and we have to move it around. This is where inverse comes in, and this is like the inverse you would have saw in a previous math class. Whenever you would have found the inverse of a function, you normally switched x and y and kind of unpacked it and redid the operation. We're going to do the same thing here. So I'm going to switch the x and the 15 over 24. So it becomes sine inverse of 15 over 24 equals x. So I'm reversing the process of sine to get us the inverse. Now, this is another important one to make sure you're doing the calculator correctly. Again, the link in the calculator video. Make sure you check that out if you're having problems in checking your answer. But this is going to go in the calculator, and I have sine inverse of 15 over 24, which gives me that x is about 38.7 degrees. This is a very powerful tool because now we can take two side lengths in a right triangle and we can find an angle measurement. We had no idea what the angles were, but by using the inverse functions of the trig, we got it as about 38.7 degrees. Let's keep going. We have theta, sine, cosine, and 1. So let's go cosine x over 8 equals 1 over 11. Now, I'm going to do cross product, or what if I just multiply both sides by 8? If I multiply both sides by 8, the left side just becomes cosine x, and the right side becomes 8 over 11. Doing cross product will get you to the same point, but it just kind of helps us sometimes in using those steps to solve. Now, cosine x equals 8 over 11. I'm looking for what value of x would give me 8 over 11 for cosine. So we're going to do the inverse. So we go cosine inverse of 8 over 11 equals x. This goes in the calculator, and I get that x is about 43.3 degrees. Now, if you haven't noticed yet, you will only use the inverse function when you are solving for an angle. You will use the regular sine, cosine, tangent when you're solving for a side. Next problem, theta, sine, cosine 1. So let's go cosine x over 5 equals sine x over 7. Now from here, let's do cross product. 7 times cosine x equals 5 times sine x. Now I have both of them here. Kind of thinking a couple steps ahead, I'm going to get to a point where I'm going to have both sine and cosine in the equation, and I'm going to have to use the inverse. But I can't do the inverse for both of them. This is where our friend tangent comes into play. We need to make sine and cosine into one function of tangent. The way we're going to get that is it needs to be sine divided by cosine. So what I want to do is divide both sides by cosine here. Then, to do that also, why don't I just divide both sides by 5 while I'm here? So now it comes out to be 7/5 equals sine x over cosine x, which is equal to tangent x. So that's gone. I'm looking at these two, and I could say tangent inverse of 7/5 equals x. So x is approximately 54.5 degrees. And that's where it gets a little bit tricky with the inverses and tangent. You have to be careful how you're setting things up and solving. Last one, theta, sine, cosine, and 1. we're going to do, let's go 41 over 1 equals 40 over sine x. Now, another shortcut that we have sometimes with cross product is all of them end up at when we do cross product, we want to get to the same result because there's not always one set way we can write proportions. We have some options. And what we can do, if we think about the cross product, the 1 and the 40 are diagonal to each other, so are the 41 and the sine x. I can switch the diagonal terms, and it still holds up to be the same cross product. So yes, that still gets us to the same value when multiplying, but what it also allows us to do is just switch them right here. And in doing that, I get sine x over 1 equals 40 over 41, which is just sine x equals 40 over 41. Now I can do the inverse. Sine inverse of 40 over 41 equals x. And we get about 77.3 degrees.